Glad you're here. Welcome to Models and Agents, episode 83 for June 17th, 2026. Lots of news to walk through. Let's start with what actually matters. OpenAI's new deployment simulation technique replays real user requests against unreleased models to surface undesired behaviors before launch. OpenAI released research showing how deployment simulation estimates real-world failure rates by running candidate models on de-identified past conversations. The method replays recent user requests through candidate models and grades completions under realistic conditions rather than static benchmarks alone. It extends to agentic coding by simulating tool calls and multi-turn interactions, while traditional red teaming remains essential for rare, high-severity risks. The approach reportedly achieves a 1.5 times median multiplicative error on held-out deployment data. Builders working on frontier systems should watch how labs fold these simulation results into future release decisions. This work continues the ongoing conversation around evaluation standardization that we have followed in recent episodes. Anthropic published fresh data showing Claude Code task value rose 27% in 6 months, while success rates stayed consistent across domains. The data tracked performance on code-related tasks over the half-year period. Success metrics held steady even as task value increased. The findings cover multiple domains without reported drops in reliability. Observers can compare these trends against other labs releasing similar longitudinal agent metrics. Microsoft Research introduced next latent prediction, which adds a self-supervised objective, so transformers predict their own next latent state alongside the next token. The method creates compact belief states that improve representation learning and enables recursive multi-step look-ahead during inference. On top of standard next token training, it delivers up to 3.3 times faster inference through self-speculative decoding. The preprint includes code and a blog post for teams training long context or reasoning models. This development sits within the current focus on inference economics and test time compute improvements. Minimax released MSA, a two-branch block-sparse attention mechanism built on grouped query attention that selects top key value blocks via a lightweight index branch. The technique matches standard accuracy on downstream benchmarks while cutting per-token attention compute by 28.4 times at 1 million token context length. It was trained inside a 109 billion parameter MSTR of experts model using a 3 trillion token budget. Inference teams handling long contexts can evaluate whether the block selection overhead is offset by the compute savings. Researchers proposed RepSelect for robust LLM unlearning by collapsing top principal components of weight gradients before each unlearning update. The method isolates forget set specific representations through this principal component collapse step. Tests spanned biohazardous knowledge alongside abusive tendency categories. It delivered 4 to 50 times larger reduction in post-relearning accuracy versus strong baselines. Experiments ran on Llama 3, Qwen 3.5, Gemma 4, and DeepSeek V2 Lite. The approach stayed robust against few-shot prompting attacks. Safety teams can examine the representation selectivity approach for deeper unlearning guarantees. MemSlides introduces a hierarchical memory architecture for personalized slide generation agents that separates long-term user profile memory, session-level working memory, and reusable tool memory. Scoped slide local revision lets the agent edit only affected regions instead of regenerating entire decks. Experiments showed user profile memory improves persona alignment and tool memory improves closed-loop modification reliability. Presentation automation teams can explore the memory design to cut regeneration costs in multi-turn workflows. This agent memory work builds directly on the reliability questions for long-horizon agents we discussed yesterday. OPD Evolver presents a slow-fast co-evolution framework that trains agents to read, use, write, and maintain experience across a 4-level memory hierarchy. On-policy self-distillation transfers these abilities into the deployable policy, and the system outperformed prior memory-augmented agents by up to 11.5% on multi-domain benchmarks. Developers building self-improving agents should examine how outcome-calibrated attribution prevents low-value memory accumulation. A study of single-step routing across a 110-agent and 584-tool enterprise catalog showed routing F1 dropping 16 to 23 points as catalog size scaled from 10 to 110 agents. Embedding-based shortlisting recovered 10 to 17 points on real traffic despite lower absolute performance. Teams operating large tool catalogs should test shortlisting layers before routing accuracy degrades further. AI Patient Arena provides an EHR-grounded, multi-turn evaluation framework spanning 8 clinical competence dimensions across 437 primary patients, plus out-of-distribution cohorts. Current models score well on questioning skills and ethical conduct, yet show persistent weaknesses in handling ambiguity, information coverage, and diagnostic reasoning. The framework surfaces interaction failures such as repetitive questioning that static benchmarks miss. Clinical AI teams should adopt similar workflow-oriented testing before deployment. PromptMN defines a lightweight pseudo-prompting DSL that annotates natural language with compact percent prefix directives for roles, goals, constraints, and outputs. Semantic resolution allows authors to write directives in any order while models interpret them by function. Early tests across Claude, Gemini, and GPT-class models showed reliable parsing of complex structures without fine-tuning. Prompt engineers working on agentic workflows can adopt the syntax to reduce context ambiguity. Researchers addressed the train-inference mismatch in token-to-token editing for diffusion language models by generating training corruptions from the model's own draft outputs instead of random vocabulary noise. A short LoRa continued pre-training pass improved accuracy while lowering unnecessary edit intensity on LLADA 2.1 Mini. The change mitigates specific failure modes, such as final digit transcription errors after correct reasoning. Diffusion model practitioners should test self-generated corruption schedules when tuning token editors. Okay, let's pop the hood on speculative decoding because everyone talks about it as simply running a small draft model then verifying. In practice, the technique is a balanced pipeline whose gains depend on acceptance rate statistics and KV cache reuse patterns. The draft model proposes several tokens in one forward pass, while the target model verifies them in parallel and accepts the longest correct prefix. Higher acceptance rates come from training the drafter on the target's output distribution, yet each extra draft token still costs compute that must be amortized. Real speedups of 2 to 3 times appear most reliably on repetitive or structured text, where acceptance lengths stay above 2.5 tokens on average. On highly creative generation, the acceptance rate often drops below 1.8, and the overhead can erase gains. Measure acceptance length on your target workload first, because if it stays under 2.0 tokens, you are better off with standard decoding or continuous batching. Test OpenAI's deployment simulation approach on your own evaluation set by replaying recent prompts against a held-out model checkpoint. Experiment with next latent prediction by adding the latent state prediction loss to a small transformer training run and measuring inference speedup. Prototype a memslide style memory hierarchy in your slide generation agent to see whether scoped local revision reduces token spend. Try PromptMN syntax on a complex agent prompt to check whether the type directives reduce downstream misinterpretation. More labs are expected to publish deployment, simulation, or synthetic traffic evaluation results following OpenAI's release. Continued work on sparse attention and latent prediction objectives will likely appear in upcoming long context model training runs. Tomorrow, keep an eye on additional enterprise routing studies that expand the shortlisting findings released today. That wraps up today's AI briefing. Share this with a developer or builder who wants to stay current. Subscribe wherever you listen. See you tomorrow And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give Unintended Consequences a listen. True stories of good intentions that backfired. You can explore the whole lineup at neuronetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.